Okay, so we have the coordinate plane. It asks us to state the coordinates of point A. Point A is actually located on one of the axes, so one of the coordinates will be 0. Which one will it be? Well, since it's on the x-axis, then the x-coordinate has a value of -3, because that's where it's located on the x-axis. And therefore, it's the y-coordinate that's 0. How do we know that? If we go across the y-axis, hits it at the origin, so that's the y value being 0. So we could actually state it this way as well, that x is equal to -3 while y is 0. The point B, okay, let's enter the values in terms of the coordinates. Point B is 3 for the x coordinate and 4 for the y coordinate. Again, we could state it as x equals 3, y equals 4. Now we have to draw, or using a ruler and pencil, draw a line through AB. So let's do that. Next, it says, hence or otherwise determine the gradient of the line AB. Now the gradient can be found using the formula y2 minus y1 over x2 minus x1. So we have to label these, right? So this is point A. So we can say this is going to be, okay, this is going to be x1, y1. It's going to be x2, y2. Okay, so now what's y2? y2 is 4 minus y1, which is 0. x2 is 3 minus x1, which is -3. Now subtracting negative is positive. So that's going to be 4 minus 0 is 4. 3 plus 3 is 6. Simplified to 2 over 3. So our gradient is 2/3. All right, it's a small m that represents the gradient. Another way to do this is to form a right angle under both endpoints, or along with the endpoints underneath the line itself, right? And then we can count the rise over run. So if we want to go from A to B, we're going to go 1, 2, 3, 4, 5, 6 to the right. So that's our run. Since we're going horizontally, 6 to the right is +6. And then once we reach here, we're going to go 1, 2, 3, 4 upwards. Going up is positive as well. So the rise is going to be 4. Notice right is positive, up is also positive. So because we're saying positive and positive, the sign will be the same. The sign will be positive. So the gradient m is the rise over run. The rise is 4, run is 6, simplified 2/3. Dividing both 6 and 4, or 4 and 6 by 2, give us 2/3. Okay, as in divide by 2, divide by 2. All right, so hopefully that was clear. Good reminder. Next, state the y-intercept of the line AB. Well, line AB should have A and B there. The graph cuts the y-axis at +2. So the y-intercept C is equal to 2. Okay. Now state the equation of the line AB in the form y equals mx plus c. Well, two things we need to replace is the m and the c, because those are fixed values. But y and m represents, those two represent coordinates of any point on the straight line, which is one way of actually getting the y-intercept, even if we weren't told what it is. But anyways, we're going to write back the y, since it's a variable. The m is fixed, that we found it to be 2/3 early on. We can double check that. You can see that the gradient is 2/3 using two different methods. So the same line we're talking about here, AB, which is gradient is 2/3. We write back the x, and the c, where does it cut the y-axis? It's at +2. So this is y equal to m, which is the 2/3 x, and the plus c, which is +2. Determine the length of the line segment AB. To find the length, we can use this formula, the square root of the rise squared. Let's use the run first. The run squared plus the rise squared. So I'm using this from the gradient formula, which is rise over run, to find the gradient. So I'm squaring these two guys, add them and square root them. That'll give me the length of AB. It's really the Pythagorean theorem, by the way. The run is what we got for the run. The run was going from this to here. That was 6 units, right? 1, 2, 3, 4, 5, 6. And we go up 1, 2, 3, 4. So 6 says be 6 squared plus 4 squared, which gives us 36, plus 16, which gives us square root of 52. Calculator for that one, and the answer is 7.2111, but the 2 decimal place is 7.21 units. All right, another way to do this is using the formula for the length of a line, which is going to be square root again, and we're going to put x2 minus x1 squared plus y2 minus y1 squared. So you have to memorize this formula, by the way, and then you're going to plug the values in for x for any two, well, the two endpoints, or the distance between the 2 points. So this is actually 3, 0 for A. This is actually 3, 4 for B. So the second x value, well, this is x1, y1. This is x2, y2. So the second x value is 3. 3 minus negative 3 being the first x value, negative 3. Put plus the second y value is 4 minus the first y value being 0 squared. And so this is going to be, subtracting the negative is positive, right? So that's 3 plus 3 is 6, 6 squared. 4 minus 0 is 4, so that's 4 squared. Notice that we have the same thing here, right? Which is basically 6 squared plus 4 squared right down here, which is what we end up with here. So we could have to simply look at the run and the rise. And the, say 6 squared is 36 plus 16, but the square root sign, square root of 52 equals 7.21 again. So that's basically finding the length of the line using the formula. But using the graph is so much quicker. All right, now next part of this, it says draw on the graph. Okay, so we are talking about this coordinate plane here, the line SD. So we'll draw the graph of the line SD, the better way to put it, which passes through the point R, -1, -1. So it's right here. Right. So to get to point R, which is -1, -1, we're gonna go 1 unit to the left from the origin. And -1 here means 1 down, so go 1 to the left, 1 down, which is right here. S, which is 5, 3. So from the origin, we're gonna go 5 to the right, because X is positive, the X and then the Y, right? So from the origin, we're gonna go 5 to the right, and then 3 up. 1, 2, 3. So it's right here. And if you check this point out, that's S. Double check it. It's gonna be 5 on X, 3 on Y, which are the coordinates of S. Then we're going to draw a line through as instructed. And looking at this, we can tell that they're really parallel, but we can't just say they look parallel. We have to prove that they're parallel. For two lines to be parallel, they have to have the same gradient. So we want to check that first off. So they can be parallel or perpendicular. They're definitely not perpendicular. If they're perpendicular, they'll be crossing each other. They'll meet actually. But these lines, you can tell that they just don't look as if they will meet. So we're going to test and see if they're parallel. We know the gradient of line AB. So we'll say recall that the gradient of line AB is 2/3, right? Write that out. What's the gradient of RS? Well, we can look at the point R and the point S, and then we just work out the gradient. We're losing space, so let's write up here for H. Let's continue. R is -1, -1. S is 5, 3. To find the gradient, we can take the subtract or find the difference between the Y values, find the difference between the X values. So it's going to be Y2. So this, let's label them X1, Y1, X2, Y2. Y2 is 3 minus Y1, which is -1. Subtracting negative is positive. That's going to be 3 plus 1. and the x values, 5 minus -1. So it's going to be adding here because subtracting negative is positive. 5 plus 1 is it's going to be 6, so it's going to be equal to 4/6, of course, which is 2/3. So therefore, RS, the line RS, has a gradient of 2/3, right? So we can continue by saying hence line RS is parallel, use a symbol to mean parallel, is parallel to which line again? AB. It's parallel to line AB, since their gradients are equal. I can say the gradients are the same. The more geometric term is equal, right? We can also check for the gradient for RS as well, right? On the graph. But I guess if you're going to use a graph, you want to show on the graph that you understand what you're doing. So this is the run equals 6 units. The rise here equals 1, 2, 3, 4 units. And then you're going to write rise over run. Gradient equals rise over run, which is equal to 6. No, rise is actually 4/6, which is 2/3. So that's the gradient. And then we make the statement, since both gradients are the same, because AB, we would have done AB before, is 2/3 as well. So once they're the same, they're actually parallel. And that's it for coordinate geometry.